So here is question number 15. It states that graph y is equal to x plus 2 to the power of 2 here. So again, it's a rational function that we're looking at. So let's begin here. Y-axis or x-axis. But again, even before we graph it, it's always better to look at the asymptote. So now we know that the vertical asymptote here is at x is equal to negative 2. Right, the denominator value is undefined at this point. Our horizontal asymptote is at y is equal to 0, again for that same reason as the previous problem, that the degree in the numerator is less than the degree in the denominator. So those are our vertical and our horizontal asymptotes. And then for slant, obviously there's none, right? If there is a horizontal asymptote, then you cannot have a slant asymptote. And then for our x-intercept, right, again, because we have a horizontal asymptote there, and x-intercept refers to the point where your graph crosses the x-axis. Well, that's not possible, so our x-intercept in this case does not exist, right? There's no x-intercept. And then our y-intercept, just plug in, it's just the value of y when x is set to 0, so 2 squared is 4, right? So our y-intercept here is 0, 1/4, or 0.25. That's your y-intercept. So we really have the characteristics here. Again, it's quite easy here. You know your asymptotes, so we can graph this. So this is the vertical asymptote here at x is equal to negative 2, and then obviously we have a horizontal asymptote at y is equal to 0. Well, that's just this. And then we're looking at our y-intercept. That's 0, 1/4. So 0, 1/4. 0, 1/4 may look something like this, I guess. Again, this is the horizontal asymptote at y is equal to 0, so y-intercept will be 0, 1/4, slightly above that asymptote. We graph this, again, looks something like that, right? Never touching those asymptotes, just approaching them. And then you will see again, because you know that this point over here, or this asymptote, is at x is equal to negative 2. So if you plot, for instance, x is equal to negative 3, x is equal to negative 4, you will see that there's a curve that looks something like that. And so this indicates that it's not always true that your curve will go, if there's one curve here, the other curve must be here, right? This refutes that fact, so that's not necessarily true. You do want to plot points and make sure where your second curve lies, since your second curve lies over here, in this quadrant over here, right? So that's your graph here, and that's question number 15. And obviously for this specific curve, there's no symmetry about the x or the y-axis. So that was question number 15. Now we have question number 16 here. So question number 16, we have the following equation. We have y is equal to 2 times x squared minus 9, and we have all of this divided by x squared minus 4. So this is our equation over here, and again, a rational function. So we want to factor this out, right? So if we factor this out, we have y is equal to 2. Again, this is a squared minus b squared, and we know that if it's a squared minus b squared, we can write this as a plus b times a minus b, right? So that's just x plus 3 times x minus 3, right? We have this, and then if we can do the same thing in the bottom, so that would just become x plus 2 times x minus 2. We have everything factored out. And looking at this, we want to determine if we have any holes, but clearly, there's no factor in the numerator and the denominator that can be cancelled out, right? So we're not looking at any holes. Our two factors in the denominator are clearly two distinct factors, so there will be two vertical asymptotes. So here we know that obviously the degree here is the same, so there's no slant asymptote, right? So there's no slant asymptote. And then our vertical asymptotes are at the points x is equal to 2 and negative 2, right? Because these are both distinct factors in the denominator. Setting each to 0 gives us that the vertical asymptotes are at x is equal to 2 and negative 2. Our horizontal asymptote is just the division of a and b, right, which are really the coefficients, because we know that the degree is the same in the numerator and the denominator. So it's just saying that that the horizontal asymptote lies is the equation y is equal to 2 divided by 1, or just y is equal to 2. So horizontal asymptote is that y is equal to 2. And then we have all our asymptotes, so now we want to find the x-intercepts and the y-intercepts. So the x-intercepts, right, are the values of x when y is set to 0, right? And really, when we're saying that y is set to 0, we're saying that the numerator is set to 0. And so in order for the numerator to be 0, this x minus 3 should be set to 0, and x plus 3 should be set to 0. So we see that we have two x-intercepts here. We have one at -3, 0, and then there's another one at 3, 0. And then for our y-intercepts, the value of y when x is set to 0, alright, the y-intercepts the value of y when x is set to 0, you just plug that in, and so you see that that's just 0, 4.5, or 0, 9 over 2, right? Just plug that in into the equation as putting 0 in for x. So we have our intercepts, we have our asymptotes, and now we can graph this. So let's just graph this here. So I can just erase this. And you see here that we don't have any holes because our factors in the denominator are distinct, right? They're not canceling out with any factors in the numerator. So if we graph this over here, this is our x-axis, this is our y-axis. And so we obviously know that there's a vertical asymptote at x is equal to 2. There's a vertical asymptote at x is equal to -2. There's a horizontal asymptote at x is equal to +2. So we have our three asymptotes. And then we know our x-intercepts. Our x-intercepts are at the points -3, 0. So if this is -2, our x-intercept would be somewhere here. And this is +2. This would be 3, 0, right? So this is -3, 0. This is 3, 0, right? Somewhere there. And so we get the idea that our graph will look something like this. So something like that. We have two curves that are going like this. And then we know that our y-intercept is 0, 4.5, or 0, 9 over 2. Right? So that would be somewhere here, right? We know this is x is equal to, or y is equal to 2, right? Because this is our horizontal asymptote. And so the x-intercept, if that's a 0, 4.5, that will be somewhere here, more on top. And then our graph here would look something like this. Obviously, you could plot more points to confirm, but that's just a sketch. So we have our curve here, we have our curve here, and we have our curve here. And so if we're asked if this is symmetrical, right, about the x-axis or the y-axis, so looking at this, it is symmetrical about the y-axis, and the reason is you get the idea here that. So you're looking at this, right? This is your y-axis, and clearly this curve, if you reflect this, gives you this curve, right? And if this y-axis is drawn, you get the idea that it's splitting this curve into two equal parts, right? Into two equal portions that they also seem to be reflecting. If you reflect this portion of the graph about the y-axis, you get something like this. Similarly, if you reflect this part of the graph or this entire curve over here about the y-axis, you'll get something like this. So this is symmetrical about the y-axis. So that's question number 16. Thanks for watching.